So in this presentation we are going to see about supercritical boilers, or it is also called as supercritical power plants. So this is how the presentation is scheduled. We have introduction, we'll see about critical condition, supercritical parameters, what is the necessity to have such boilers, comparison of the regular boiler which is subcritical and the supercritical boiler, types of boilers, drum type boiler, once through boiler, advantages of once through, and finally we'll conclude. In the last presentation we saw about the Rankine cycle, and only if we understand what is the Rankine cycle and what are the different stages of the Rankine cycle, we'll be able to follow this presentation. So if you have not gone through the Rankine cycle, so you can please go through the Rankine cycle presentation and then come back to this one. Power plant which operates above the supercritical conditions are called as supercritical power plant or a supercritical boiler. Now, what is a supercritical condition? Critical condition is a thermodynamic expression describing the state of a substance beyond which there is no clear separation or distinction between liquid and gaseous phase. Both the liquid and gaseous phase are going to be the same above the critical condition. Now this is the critical point. That red color point is the critical point where the pressure is 225.56 kg per centimeter square and the temperature is 374.15 degree centigrade. Now above this particular point you see a inclined line. This line is the supercritical line and this line is subcritical line. In the Rankine cycle we saw the first stage, that is in the pumping stage, the process goes from here to here. Then after that, during the boiling, there is basically two phases, that is liquid phase. From the liquid you get water bubbles, that is the steam, and then here it is fully steam. So this is subcritical where the boiler, normal regular boiler, operates with a less pressure, maybe 100 bar. But here what we are going to do is we are going to increase the pressure. When we increase the pressure, water automatically turns into steam. So that is the advantage of using a supercritical boiler. Now why this particular advanced supercritical boiler? Because the efficiency of the Rankine cycle increased with increasing turbine inlet temperature and pressure. So increase the turbine inlet temperature and pressure. What we are going to do is to follow a supercritical, boiling. The cycle efficiency of a typical subcritical power plant is less than 38%, where in supercritical technology we can go up to 47% efficiency. So this red color thing, red color line, what we see here is the regular boiler, or it is the subcritical boiler. So in the subcritical boiler the boiling takes place. So this horizontal red line, what we see here is the boiling. This is basically your enthalpy entropy diagram, or in the vertical axis you have the temperature or enthalpy. So almost the temperature is constant throughout, and during which your water boils. Now after the entire water boils, then only the temperature of the steam increases. So this is called, this temperature is maintained constant here. It is because of the latent heat of evaporation. And when you come to this blue line, this supercritical boiler, so when you increase the pressure of the water at inlet, automatically the water goes out of the bell curve. That means out of the bell curve the water is going to be steam, and inside the bell curve the water is going to be what is called the water plus vapor. So this energy is unavailable. This energy, that is the latent heat of evaporation, it is the energy absorbed by the water for converting from water to gaseous state or water to steam. That phase conversion, for the phase conversion some amount of energy is lost, and that doesn't happen in the blue line. The blue line is supercritical, where initially what we do is we increase the pressure. So when the pressure is increased, the water goes out of the bell curve at the initial stage where it becomes vapor, but the temperature of the vapor is less. See here, this is the temperature of the vapor. It is almost equal to the room temperature. So what we are doing, we are increasing the temperature. As we increase the temperature, the vapor slowly increases its temperature, and at some particular point it becomes steam. That is very hot steam. And here at, it goes up to 500 degrees centigrade. And this first vertical drop of the blue line is the expansion through the first turbine. Then again we heat it during that is the we have the heater, and we heat it, and it goes to the second peak, and then it drops. This is the second stage, and here is where this is converted to water back again. Then we take the water back, and then we pump it. At this particular stage we increase the pressure so that it becomes vapor at the initial stage. So this is the organic Rankine cycle. So in organic Rankine cycle we have a pump. So this is the organic fluid which goes to the boiler, and in boiler it boils. This is the steam, and then we have the superheater, and from the superheater it passes through the turbine, and again it comes to the condenser. So this cycle continues. Okay, so in the supercritical boiler, what we normally do is we have a pump, then we have a vapor generator, then we have a turbine and a condenser. Now, what are the differences between supercritical boiler and the regular boiler? The pressure is less than 190 atmospheric pressure in subcritical boiler, where in the supercritical boiler it is greater than 240 atmospheric pressure. Flow in water wall, that is two phase. In subcritical you have the liquid phase as well as the gaseous phase, but in supercritical everything is gaseous. The efficiency of the cycle is base, and in supercritical it is plus 2 to 3%. Fuel saving, it is very basic, but in supercritical it is 8 to 10% approximate. The boiler weight of the supercritical is 10% more than the subcritical boiler, and the number of stages of reheating between the turbine is 2. Types of boilers, you have drum type and one screw type. One screw type, in the sense the water passes the boiler at once and it does not recirculate. The natural circulation normally is used in the regular boilers, where the pressure is less than 175 kg per centimeter square. In natural circulation we have the pump, then we have the economizer, and from the economizer it goes through the boiler here, and then there is some amount of water which is not evaporated completely, so that water is again recirculated. The water is taken, recirculated, and goes through the economizer. Only there is a separator which allows only the steam to go out. But in a once through boiler, this is a drum type boiler, or it's a natural circulation boiler. The circulation through water walls by thermosiphon effect. The controlled circulation boiler, it's a high operating boiler, where the pressure is kept below the critical pressure levels. Thermosiphon effect is also supplemented by pumps to ensure the safety of the furnace wall tubes. This is again drum type boiler. Steam generation especially takes place in the furnace walls. There is a fixed evaporation end point, and as far as the steam is concerned, water separation takes place in the drum, and the separated water mixed with incoming feed water and fed back to the water wall, that is the lower drum, by means of boiler water circulating pumps. This is the once through boiler technology. This is used in the supercritical boilers, where we have the economizer, then we have the heater, and then it goes to the superheater. In once through boiler, through forced flow, or that is using pumps, the water is pumped through the economizer where it is heated, and then we have the water walls and then superheater. Heat pumps provide the driving head. This is suitable for subcritical as well as supercritical pressures. In once through